The first speaker will be Jim Bell. Okay? Jim Bell is an astronomer, a planetary scientist, a professor in the School of Earth and Space Exploration at Arizona State University, and he's also an adjunct professor at Cornell. He's been deeply involved in many NASA robotic space missions, including the Mars rovers, Sojourner, Spirit, Opportunity, and Curiosity, the one that is on the pad now, ready to be launched this month. He's been deeply involved, and also the Mars Odyssey and Mars Reconnaissance Orbiters and the Lunar Reconnaissance Orbiter. He helps provide science and policy advice to NASA and is currently the acting chair of the Planetary Science Subcommittee of the NASA Advisory Committee. Jim is a prolific and passionate public advocate for science and space exploration. He's written many magazine articles, blogs, popular books. He's got a great book about the rover mission. He's appeared on numerous TV shows. He was awarded the 2011 Carl Sagan Medal by the American Astronomical Society for excellence in public communication of planetary science. And he's also president of the Planetary Society, the world's largest public space advocacy organization, and co-sponsor of this event. So, Jim Bell.
So I'm delighted to be here today to share with you some of the excitement of planetary science and help tell the story of the many ways that NASA's exploration of the planets inspires, educates, and benefits our nation. This is an amazing time in the exploration of space. Oh, now I can't read my notes.
Sorry.
That's all right.
Please, everyone just leave things to
That's fine. Thank you. So we're all in what my ASU colleague and historian Stephen Pine calls the third great age of exploration. In the first age, there were Renaissance explorers like Magellan, like Columbus, and Amerigo Vespucci, who discovered a so-called new world right here on our own planet, mapping new continents, circumnavigating the globe in their 15th and 16th century sailing ships. And then in the second great age of exploration, 17th to 19th century, Enlightenment explorers like Captain James Cook, Lewis and Clark, John Wesley Powell. These folks helped to push our exploration deep into those frontiers, discovering and documenting the details of those new lands and new peoples. And of course, at the same time, the scientific giants of the Enlightenment, Galileo, Brahe, Kepler, Copernicus, Newton, they helped us to learn how we could eventually explore the realms of the cosmos beyond our earthly home. The scientific revolution that followed in the 19th and 20th centuries went on to make their dreams a reality. And that's where we are today, in this third great age of exploration. We are living the dreams of our ancestors by exploring literally new worlds around us and by extending our human senses into deep space using the technological wonders of rocketry, computers, and robotics. But unlike the explorers of old, global communications and the internet are letting us take everyone with us this time. School kids, teachers, parents, politicians, anybody who's interested in age-old questions like how did we get here, where are we going, are we alone? Modern explorers work hard to share the adventure and scientific discoveries of space exploration with the public and to justify the investment and public trust that we have been blessed with. So let me give a brief sampling of just a few of the most recent stunning and exciting discoveries in planetary science and what they mean for life on our own world, what they mean for our future exploration of the solar system. And I'll start with Mars because that's where I spend a lot of my time these days. In the last decade and a half, think about it, there have been 4 orbiters, 3 rovers, and 2 landers that have absolutely revolutionized our understanding of the red planet. For example, confirming that there once was liquid water on the surface and in the shallow subsurface. That's a pretty spectacular thing. Combine that with the abundant potential heat sources on Mars and the potential supply of organic molecules, then that has made Mars become the #1 off-world, potentially habitable destination to search for evidence of life beyond our home planet. And pretty soon, as Robert mentioned, NASA's Mars Science laboratory Curiosity will begin its mission designed to find those possible organic molecules and other proof of the past habitability of Mars. And that rover is on schedule for November 25th launch. It's all looking good. The board is green right now. So exploring Mars is a critical part of the search for our own origins. Indeed, my colleagues in the planetary science community recently completed a 3-year decadal survey process, which you'll hear more about soon from my colleagues here. And that process concluded that the next step in that search and the highest priority new flagship class mission to carry out in the next decade should be a joint NASA European Space Agency rover that will be the first part of a multi-decade effort to collect a set of Martian samples that will eventually be brought back to the Earth for detailed study in future decades. Our colleagues in Europe are an important part of this. They've agreed to contribute more than $1.2 billion to partner with us on this mission, helping it to fit within the cost cap identified by the decadal survey. Now, these robotic missions are our eventual scouts. There, keep up with my slides. These robotic missions are our scouts for the eventual human exploration of deep space, and it's important to point out that the current and the previous presidential administrations have affirmed that Mars is the ultimate destination for future human exploration of the solar system. Moving on a little bit farther out, we think of our planet Earth as the solar system's only ocean world, but that's not really the case. It turns out that NASA's Galileo mission discovered that one of the large moons of Jupiter, Europa, is a place that appears to have a substantial liquid water ocean under its fragile, icy, salty crust. Because that ocean is warmed up by tidal heating from Jupiter and the other satellites, it may be another rare zone of habitability right here around the solar system. And because of that, partly the Planetary Decadal Survey identified the Europa Orbiter mission as the next highest priority new flagship class mission destination during the coming decade if NASA's budget can be augmented. You may have noticed that Jupiter is gleaming very brightly in the night sky tonight. It's a very prominent object in the clear night sky. And so next time you look at it, just think about the fact that some of that light is coming from another world out there with an ocean that may be larger and may be more exotic than our own. Now, in addition to Mars orbiters and rovers, NASA scientists, university researchers and students, and our international partner space agencies are also operating orbiters around the Moon, around Venus, around Mercury, around Saturn, around the asteroid Vesta, and pretty soon around a distant comet called 67CG. The Lunar Reconnaissance Orbiter and Messenger missions are revealing the geology of the Moon and Mercury in unprecedented detail, including the discovery of ancient water in the lunar crust. Pretty exciting. The Cassini mission at Saturn has revealed the astounding beauty and mathematical complexity of the rings of Saturn, as well as discovered lakes of liquid hydrocarbons, ethane and propane, on its large moon Titan. Pretty spectacular. Other flyby missions are exploring the sun, comets, asteroids, and in just a few years, the New Horizons, New Frontiers mission will encounter the planet Pluto. In addition to the samples of the Moon brought back by the Apollo astronauts, researchers are also studying samples of the solar wind from the Genesis mission, comet tail from the Stardust mission, and now samples of a near-Earth asteroid from the Hayabusa mission. There is just so much going on. It's an incredible time in planetary science. These amazing kinds of planetary science discoveries continue to pour in from telescopes, too, including the ground-based observatories that are addressing the threats from asteroids and comets that may be potentially hazardous objects. They're finding those potentially hazardous objects that could possibly encounter the Earth in the future and documenting them at their orbits and monitoring them very carefully. The venerable and aging Hubble Space Telescope continues to be a great tool for planetary science, recently studying a giant storm on Saturn, providing new data on a small asteroid that crashed into the clouds of Jupiter, and discovering a fourth moon around Pluto. These are just in the last year or so. When Hubble's successor, the James Webb Space Telescope, becomes operational later this decade, it will enable even more exciting planetary science discoveries related to planets, moons, asteroids, and comets in our solar system, as well as planets around other stars. And that's the last sort of highlight I want to hit that's truly exciting. We now know of nearly 700 planets orbiting other stars. That number is increasing all the time. Major advances from the Kepler mission and other observatories in space and on the ground. We are on the verge, in fact, of making an incredible discovery, and that is finding other Earth-like worlds out there around nearby stars. Do they have habitable climates like ours? Is there life out there? We are right on the edge of making those kinds of discoveries. Incredible time. This, that summary includes just discoveries from the last handful of years, and even still, it's only a partial list. I could go on for an hour talking about NASA's heritage of discovery back in the 1960s, but I won't. The point is that all of these incredible discoveries have been made possible by American taxpayers and by the vision of our elected representatives. These are examples of all of us and our government enabling something wonderful, inspirational, far-reaching, and historic. I believe that exploring the solar system is the modern incarnation of the American pioneer spirit, extended out to worlds beyond. I'm proud of the leading role that our country is playing in the international exploration of our solar system and other solar systems, but, like many of you, I'm worried about the effect that potentially drastic budget cuts would have on our space program and their effect on our leadership in planetary exploration. I give a lot of public talks around the country, and so I know firsthand that NASA's achievements in planetary science are a source of immense pride among Americans and people from other countries as well. NASA's discoveries and adventures educate and inspire our young people to learn about science, technology, engineering, math. Space exploration creates thousands of high-tech jobs around the country in aerospace companies, government, industry research labs, and universities. Stable, healthy funding for NASA yields strong, tangible, and intangible returns on investment, and I believe is a priority for the future of our nation. As a civilization, we've been on a 500-year journey of exploration of our planet, our solar system, and other solar systems. And it's thrilling to think about what the next 500 years is going to reveal, let alone the next 5, which is going to be pretty spectacular too. It's also uplifting to realize that in our relatively young, complex, and fragile civilization, we're still willing to expend a small fraction of our collective wealth to reach out beyond the challenges and confines of our pale blue dot and learn about what lies beyond. Thank you. I turn it over to Tom.
Thanks. Okay, our next speaker will be Heidi Hammel. Dr. Hammel is the Executive Vice President of the Association of Universities for Research in Astronomy, AURA,